Assalamualaikum.
warahmatullahi
wabarakatuh.
My name is Muhammad Nais Ifan bin Muhammad Nazri.
My name is Nadia binti Basir.
My name is Muhammad Hafizul Akmal bin Muhammad Noor.
In this video, we will present our final year project named Smart Planter System. So firstly, what triggered us to do this project? Agriculture is one of the most important sectors in our country, Malaysia, and contributes to the excellent progress of import and export around the world. So we introduced automatic planter watering system, which is considered as one of the most used and the most beneficial automatic system nowadays, which is a model of controlling plant needs that uses sensor technology to sense soil moisture and the need of fertilizer with a microcontroller function to make a smart switching device to help millions of people, especially in keeping their plants healthy. So we live in the age of advanced electronics and technology where our life should be simpler and more convenient. There is a need for many automated systems that can replace or reducing human effort in their daily activities and jobs. The significance of our project is to help people in their activities in keeping their plants healthy, especially the one goes through the hectic day, by reducing or completely replacing their effort. Secondly, people can easily make their own and cheap automatic plant watering system in just a few hours by connecting certain electronic components and other materials for cheaper price. Hence, this leading to the objectives of our project. The main purpose is to design a small vase with automatic irrigation system of water and fertilizers, and to control the exact amount of water and fertilizers that can help the growth of the plant.
Next, for the methodology. In this model, the main part is Arduino Nano. Arduino Nano was connected to the important parts, which are the soil moisture sensor and pH sensor. Measurement of soil moisture and pH soil is done by the sensor, which forward the information and parameters regarding the soil moisture and pH soil to the microcontroller, which control the pump. If the level of soil moisture drops below the certain value and level of pH soil was not suitable, the microcontroller will send the signal, which then run a pump, and certain amount of water and fertilizer is delivered to the plant. Once enough water is delivered, the pump stops doing its work. Since the complete system should be embedded in a small box, Arduino Nano is a perfect microcontroller for this purpose because of its dimension and its work performance. Water pump is connected to the Arduino and it only works when the Arduino get a signal from the sensor. This circuit can be worked by using a 12-volt battery. For the next part is result. In this work, the moisture content of the soil of cultivate land can be monitored. Our result get from collect the data of volume water applied to soil by the certain moisture soil level. Our result for moisture soil was divided into 3 different soil, which are sandy soil, clay soil, and loamy soil. Our analysis know that different soil has different volume for water applied to get a suitable moisture soil condition. Next result, for the volume of fertilizer. Volume of fertilizer will add to soil. Our result was describing that different fertilizer will add by following the pH of soil with acidic fertilizer or alkaline fertilizer. When the soil's pH soils below than 7, alkaline fertilizer will be added. and when pH upper than 7, acidic fertilizer will be added.
The purpose of this smart planter system is to design a small vase with automatic irrigation system of water and fertilizer. The highlighted part of this system is on microcontroller Arduino, which controlling the signal from soil moisture sensor and pH sensor. In order to control the exact amount of water and fertilizer, the system works on the principle of measuring the soil moisture level and pH soil level by means of the sensor technology, which in turn control the water pump via Arduino microcontroller in order to provide the plant enough amount of water and fertilizer when necessary. There are a few advantages of this smart planter system. An automatic irrigation of watering and fertilizing eliminates the need of human interference. The system can automatically water and fertilize our vase without bothering the people around when they are out of the home area. This system consists less components compared to previous model, hence it's compact than previous system. Therefore, it will reduce the cost of this system and become more cost efficient, which the system does not need any heavy and expensive component for implementation. This system gets low cost to develop because we are producing a small scale of huge irrigation system. By that, the operating cost includes cost of electricity will reduce the current. Every project has their own limitation from different aspects. The limitation of this smart planter system are the operation of the system only depends on the battery. The capacity of the batteries doesn't last forever. Hence, it needs a continuous power supply, which is direct to the power plug. Besides, this system should be observed from week to week. It is because the system is not provided direct water and fertilizer supply. This smart planter system operates without a programming, so it can be operated remotely through smartphone with help of developed app, and the data can be stored and accessed through internet. For the conclusion, as a matter of fact, the smart planter system is the solution to the improper irrigation and watering problem for plants. This will not only increase the crop yield, but it will also prevent water wastage. The system is also very flexible as it is used in the agricultural, domestic and industrial sector. By using a battery, this device can be regarded as self-sustaining. There is no wonder, however, that this system can be very helpful in solving many problems, depending on how it is designed, from those that seem harmless to those that are on the scale of the most important and the most dangerous problem for human population. There are a few recommendations for this smart planter system. First, make a hydroponic plant system. Hydroponics is the practice of growing crops or plants without soil being present. It uses water enriched with nutrients that are necessary for the growth of plants in order to eliminate the need for soil. Next is installation of disease detection. We can use automated detection techniques to detect or classify any disease that is caused by our plant, which will require less effort and less time. It is possible to interface a camera with the device and then apply image processing and machine learning to capture image of the farm. And lastly is running this system with help of mobile application. We aim to create an application for consumers so that their plants or crop can be tracked remotely. This app will also allow the user to turn on and off the system or only specific part of the system. That's all from us. Thank you.